Hi guys, I'm Mikhail Foenko, or Mikhail Foenko if you want to go with the correct pronunciation. I'm going to be talking about using Jetpack Compose to create apps from Figma UI sketches. Before I start, is anyone here from out of town? Like you're visiting New York for DroidCon? All right, a lot of people. I want to teach you a little bit of New York slang to warm up the room a little bit. Close. We have a word yer, which is used as a greeting. It's pronounced yer. When I give you a yer, it is important, it is polite to yer back. So when I yer, can you guys please yer back to warm me up a little bit here? Yer. Awesome. All right, so the talk is originally called this, but I thought it undersold the concept of what I was doing a little bit, so I've revised it slightly. We're using Jetpack Compose to magically create apps from Figma UI sketches. So to explain, the typical process would be you get a Figma UI sketch, you have a developer write some Compose code that looks like your Figma UI sketch, and then your app runs that code and it looks like your Figma UI sketch. Everything's great, right? What we want to do is cut the developer out of this completely. We want to take Figma, take the data off of Figma, and write Compose code to generate Compose for us in the app, so that changes we make in Figma are automatically reflected in the app. So it's a little bit like server-side UI rendering, maybe. It'll be fun. So I'm a staff Android engineer at Lunchbox, and Lunchbox is a startup that I co-founded with a bunch of friends, and we solve technology problems for restaurants. One of the main problems we're solving is online ordering. So we provide online ordering solutions to these restaurants who otherwise would have to pay some company to build a big app for them. So we white label this out. And our clients, the restaurants, are very picky, which can be annoying, but being picky isn't necessarily a bad thing. So I'm a very picky person. You can ask my girlfriend, who's in the back over there. When my microwave broke, it took me 6 months to pick out a new microwave. And 6 months is a long time to live without a microwave, at least in America. So being picky isn't necessarily a bad thing. It means you care. So I care about my microwave's user experience, which is why it took me 6 months to pick one out. But our clients really care about their branding, which is very important to them. So on screen, we have the Lunchbox app, and this is our location pickup screen. And these are just 5 of our 90 Android clients. And you can see from left to right, obviously all of the colors and fonts are completely different, which is already annoying. But from left to right, WingsOver has square buttons that say selected and select. Clean Juice has rounded buttons that always say order now. Bear Burger has square buttons again, and they have borders around them when they're unselected. Inday doesn't have buttons at all. Are you kidding me? And you're supposed to click the cards to select a location. And Tacombi has to drop shadows, and they're the only client with drop shadows too, so it took forever to figure that out. So I don't want to write all this code. I don't want to have to configure all these clients because it takes forever, and I'm a developer, and developers are a little expensive. But what they all do have in common is that we write all these in Figma. So our designers design layouts in Figma, and they present them to the client. The client approves them, and then the designs go to us developers, and we make apps out of these designs. What we're most interested in Figma, among its huge feature set, is the ability to use an API to fetch our design data, that last bullet point. And we're going to be putting that data into Compose, which I'm sure you've heard of. It's a UI toolkit for Android. It's really cool to build UI with. You get lots of cool free animations. And we're going to be using some of the underlying features of it, some of the stuff that it uses to make such a good user experience. And we're going to create our own bit of a UI toolkit. So our problem is that creating apps is expensive. As you can see, we have so many variants. And our solution is to just make our designers do it for us. We're done right now. We're going to have layout information coming in from Figma, and we're going to parse that, and we're going to render it all in Compose. I want to give a quick disclaimer. There's a lot of stuff to go over. I'm going to be speaking kind of fast. It's very dense. I'm going to backtrack sort of often so we can go back and make sure we're learning the concepts that we're going through. But I only have 35 minutes to get through a lot, so I might be a little speedy here. So let's just get right into it. We're going to start with the most basic piece of data I could think of in Figma, which is just a piece of text on a screen. And we're going to use this as an exercise to get Figma data and try to render it in Compose. So on the left, we have our screen that we wrote in Figma. On the right, we have the JSON that is outputted from the Figma API for this particular sketch. I was going to say that I couldn't read that, but I actually can, but it's too much information, okay? We're going to cut down on the amount of information we're getting from the API. So we're just going to extract the middle piece there, which is actually just the JSON data for our text element on the screen. So you can see it's of type text, it's got a name that's hello world, it's got characters, which is a string being displayed in the text, which is hello world, font size, font color, cool stuff. We're going to simplify this even further into just the information we need. So we're going to have a parser take this huge JSON file and condense it into something our apps will use across our iOS, web, and Android apps. So we have our string coming from characters, we have our fill color, which is the color of the font size, great stuff. We're going to take this and we're going to use Moshi to parse it into a Kotlin data class. So finally we're hitting some Android code. This is just a one-to-one mapping, nothing too complicated. We are using an enum, that's about the most complicated thing here. And now we're going to use this label structure, and we're going to call all the data coming from Figma structure. We're going to use that structure, and we're going to pass it into a label composable, which is a composable we will write. This composable is just calling the Compose UI text element, and it's just going to be passing in data from our structure into the text. So it seems like a lot, but all it is we're taking text, we're getting rid of null values. We're taking color, we're parsing it from RGB to a Compose hex color. We're taking font size and giving it a unit, all kinds of stuff like that, just adapting our data. Finally, we just have to call our new composable. So we're going to have a parse JSON method that just runs Moshi and parses our JSON. We're going to pass it in as the structure for this label, and we're going to call this label and set content. And now, when we run our app, it works. It's beautiful. We have hello world there, and our app says hello world. Isn't that exciting? A little bit? Yeah? Obviously, this is a little bare bones. We can go ahead and modify this, so we can just make our text big and blue in Figma, and when we run our app, without making any changes to any of the code we just wrote, it's big and blue in our app as well. Obviously, this is not a lot, and we still have 30 minutes left, so we're going to get into some more complicated stuff. For example, we can do 2 texts on a screen. And to do that, we're going to have to lay out our text, right? So we have to make a layout to place our components on screen. Figma has an excellent tool called Figma Auto Layout. You can create a frame and set it as an auto layout, which is that pane over there. You can set a direction for the auto layout, and this enables a bunch of cool functionality like hugging and filling your content or your elements in the layout. It enables you to distribute them so you can align them center, left, top, bottom, whatever. And effectively, it's just a row or a column in Compose. And we now have to parse this data. So our data scheme is going to change a little bit. We're still getting our main element, but now this has nested children in it, and it's going to be kind of annoying to traverse through our data to find all the children if we have some deeply nested layouts. So we're just going to pull out the names of our children, and we're going to keep the direction of the list and get rid of everything else for now. In the future, we have implemented alignment and arrangement, and we'll get into that. We won't explain it, but I will show it. So now we have the names of our children, and these names are just the names of the layers in Figma. So we have this little layer screen, and our hello text is the hello element, and our world text is the world element. We're going to parse this into a linear layout structure, just direction and array of strings for our children. And now we have the problem that we have 2 different types of structures, right? We have labels, we have linear layouts. We have 2 different types of elements. We are going to group our elements by type. So this is going to be on our parser side. It's going to parse every element on the screen. It's going to take all the labels, put them together, and it's going to map them to their name. So we have a map of labels, and we're mapping the name hello to the text element on screen that displays our hello. Same thing for world. And in our linear layouts, we're going to map the screen, which is our root layout, the auto layout we saw. And we're going to map the structure data to that. And in Android, we will write a data class that encapsulates that. We have labels, which is a map of strings to label structures, and linear layouts, which is a map of string to linear layout structures. Still very simple, just kind of dense. Now we need to provide our Figma data. We're going to use a cool tool called composition locals. I won't get too deep into it, but it basically acts a little bit as like a static variable almost with some fun extra functionality. So we declare this like global constant called local Figma data. It is a composition local, and we're going to pass it a default instance. In this case, we're going to call this getInstance function, which again is just our JSON parser, Moshi, whatever. Now in our composables, we can use local Figma data.current to get the current value of this composition local. In this case, it's going to be our default. In the future, if we wanted to break up our JSON into multiple files so we don't have this huge monolithic JSON, we can use composition local provider composables to provide a set value for our local Figma data. So for example, we'd create a screen, we'd pass in the JSON, and then all of the children of this component, or this, composable, when they query local Figma data.current, they'll instead get this provided value instead of the default. And if no one is a child of a composition local provider or is just not the child of the composition local provider, it'll get the default instance, which is just our Figma data.get default instance. Not too important, but cool, thought I'd share. So now we're going to write a new composable, which we saw on the previous screen. We're going to call it label by ID. So at this point, we have a big Figma data, and we have IDs or names mapped to structure data. So at this point, we don't need to pass around structure data directly. We can just work with IDs. So we're going to call our label by ID. It's going to get an ID, and it is going to look up its structure from that local Figma data. It's going to look in the labels, and it's going to grab the structure with the ID that we passed to it. And it's just going to render the label using that structure that it just fetched. Very cool. We're going to get into why we're doing this, but we're going to do the same thing for linear layouts by IDs. And we're actually going to write our linear layout composable now. We've done all this boilerplate. We're finally back to writing more Compose code. So we're going to use layouts under the hood. This is the same thing that row and column uses, and I swear there's a constraint layout in Compose that I don't think I've ever touched, but it also uses a layout under the hood. Layout takes two parameters. It is content and measure policy. Content is a composable function, and when it's called, it'll generate a bunch of composable nodes, as Compose does. And those composed nodes will be passed into the measure policy, which figures out where to place them on screen and how big to make each node, which is how layouts work. So we're going to start with the easier of the two. We're going to start with our content, because we just have to generate a bunch of composables here. At this point, we have two different types of composables. We have linear layouts and labels, and we have IDs that could be either type. Let's make one composable that can figure out which type we're working with and render that one. So we're going to make this composable called Figma Composable by ID. It is going to take an ID, and then it's going to look through our local Figma data for the ID in linear layouts and in labels. If it finds it in linear layouts, it'll create a linear layout by ID with that ID, and if it finds it in labels, it'll create a label with that ID. So they're still pretty simple. These are doing just very simple isolated tasks. This one is figuring out which type of composable to render, and then label by ID will figure out how to get its structure data, and then label will figure out how to render that structure data. So we're feeding back to what we had earlier. Make sure I didn't not mention anything. Don't think I forgot anything here. So now we can plug in our find composable by ID. Our structure has an array of children, just an array of strings. We're just going to loop through that, and for each string, we're going to call Figma Composable by ID, and we're going to pass that in. So if you remember, our children were just names of other elements on the screen, and this Figma Composable by ID will look up those elements on the screen and just display them out. Now we just need a measure policy to figure out how to place this. Luckily for us, Compose uses something called row column measure policy for its rows and columns. And like we mentioned, this is just going to be a row and a column. The reason we didn't just use a row and a column is a little bit complicated. The content parameter for that is called off of a row or a column scope. And those have modifiers which we'd want to use in the future, but because we don't know if we're in a row or a column, we can't really work with it, which is why we have to make our own layout. And now we're making our row column measure policy. So usefully, this has an orientation. So at the end of the day, the rows and columns both call the same layout code and just pass an orientation, even though they're two separate composables. So in theory, we could have had a linear layout in Compose that took an orientation. So we could just use this, but we can't because this is internal, which means we can't access it. We're so close. Has anyone ever run into this? Like you have some code you want to use, but it's like internal, or maybe like you're trying to extend like an Android view, but it's final, so you can't do it. You guys ever solve that problem? You guys ever figure out how to do that? I have, and I've just copy and pasted entire code bases. So we're going to copy and paste all of row column measure policy. It's going to be Mikhail's awesome measure policy. We'll call it linear layout measure policy, whatever. And the only change we're gonna make is instead of passing an orientation as a parameter, we're just gonna grab our orientation from our linear layout structure, which we're taking as a parameter here. There were more parameters for row column measure policy. We set up some default values. There's not enough time. There's just not enough time. So we're gonna skip over those real quick. Now we can just plug in our measure policy. So we're calling linear layout measure policy, and we're just passing in our structure. We could have just passed in our orientation in this case, but in our actual project, there's a lot more coming out of that structure, so we opted to keep it all bundled together. So now let's look over how our code is going to render. We have a root linear layout that might have children linear layouts and labels. Either way, it's going to call Figma component by ID. So it's going to iterate through its children. It's going to call that function. For the case of call, it's going to find call in our linear layout, so it's going to render a linear layout. And then for our label child, it's going to be named world. We're going to look it up, and we're going to find that it's in labels. And we're just going to render a label world. So this is kind of like how our Figma composable by ID, Figma component by ID is agnostic, and will render whatever type. And then this is recursive because linear layout will, again, search through its own children, and will create labels for those. At this point, all that's left is to call our new layout as the root element of our screen. And we don't even have to specifically call a layout at this point because we can use this type agnostic Figma composable by ID. And as long as our root element is called screen, it doesn't matter if it's a label or a linear layout, and we can just render it out. And when we run this, lo and behold, we have hello world oriented vertically rendering correctly and oriented horizontally loading correctly. So we've made substantial progress. We now have hello world split up in two. We could do some more interesting stuff, so we can nest some linear layouts. So in this case, we have hello epic world, and world is in big blue text, and it's in a row with a column, and that column has hello and epic in it. So we're getting pretty interesting. And between those two examples, again, we never changed our underlying code. We're just rendering what Figma gives us. So this is pretty cool. But at this point, we're just rendering static content. We don't have any functionality. We can't have our designers say, hey, I need this button to do something, right? So we've had buttons in our apps before. And sometimes our buttons do something. And usually in our demo apps, our buttons increment a counter and then display that counter. So that's what we'll do. So we're going to make some buttons. And rather than a new element type, this is just going to be Figma elements that tie into some executable code. So we're going to add a link to our Figma. We're going to call it link, and the name is link, and the text is something different this time, which is cool. We're going to color it blue, which is very important because users need to know you can click on this. Now, what we want to do is we want to hijack our renderer, and rather than making a static component that is just a link, we want to create a dynamic component that will execute some kind of code. And the dynamic component is just going to be some arbitrary composable in our project. So during our lookup process where we find or when we try to render an element by ID, we're going to first find if we have a dynamic component or not. If not, we'll just do the static component like we were doing, which will render some Figma data. And if we do have a dynamic component, so some composable we want to tie here, we'll display that instead. So there's a couple of ways we can try to do this. We're going to start with the obvious one, which is map. We can do a map of strings to strings. We can do a map of strings to functions. And we should be able to do a map of strings to composable functions. And then we could just call this map to see if a composable is mapped to a specific ID. We are just constantly running into roadblocks. Oh my God. We get an error in the compiler. Function references of composable functions are not currently supported. So function references can't have annotations, and this used to give a horrible error that I couldn't even understand, but we figured it out. But in the darkness, we find light. There's a hint to an approach we can take, and that is what every great Android library does. Think of like Retrofit, Moshi, Compose. They all have one thing in common. Jake Wharton. No, they have annotations. And annotations are parsed with annotation processors, and they generate code typically. So we're going to generate a ton of code. So first, let's start by making our annotation. We'll call it dynamic component, and it'll take ID as a parameter. So this ID is what we're going to use to look up a function annotated with this annotation. Now let's write some functions and we'll annotate them. So we have some specific ID annotating some composable in our code, and we have some other ID annotating some other composable. what we want is to generate a function like this, where we can pass an ID as a parameter, and based on what the ID is, we can render our composable. So for some specific ID, we will get the some composable in our code called, and for some other ID, we'll get some other composable. One thing we also want is to fall through to our Figma composable by ID. So if we can't find a dynamic component, we're going to render a static component, just like in the little flowchart we made. This is our annotation processor. I'm not going to explain it. It's running Kotlin Poet, so it's a very cool, very handy library. And we're going to generate that big when statement in a function. At this point, we can create a dynamic component. So we're going to call it link, which, if you remember, was the element in our Figma file. This component is actually going to do some cool compose stuff. It's going to have a variable for the number of times it's been clicked. It's going to display that variable, and it'll have an on-click modifier that will increment the variable when it's clicked. And just for kicks, we're going to show a toast on screen just to be able to show that we can do some more functionality here. And we're getting context from a composition local provider, which is very cool. Still love those. Now, when we rebuild our project, we're going to get this generated function. And as you can see, it's generated because the indentation's horrible and the function names are fully qualified package names. But we do have link, and when the ID is link, we're going to call our link function. And when the ID is not link, we're going to call our Figma composable by ID. So this is great. This is automatic. We don't have to even manage like a list of dynamic components. We just have to write them. Interestingly, this is still as efficient as the map, because the when will compile down to a jump table in Java bytecode, and here's a snippet from a Medium article that I can use to not have to explain it myself. Finally, we're going to update our linear layout. So this is what's responsible for rendering all of our items. Rather than find composables by ID, we're going to call our generated function dynamic UI composable, and we're just going to pass the ID of our child. Once again, just to rehash this, because I love to go back over things, we're going to try to render our elements. We have an ID for it. We're going to try to find a dynamic component, and if we do, we're going to render that dynamic component, and if we don't, we're just going to render a static component based off of Figma data. And when we run this, it seems like it works. We have a link, and we can click on it, and when we click on it, we get our toast, and we keep track of the number of times it's been clicked on. But if I showed this to the client, they would wring my neck. That link isn't blue. How are users going to know you can click it if it's not blue? All right, so we messed up somewhere. The problem is all of our functionality of getting text color and all that fun stuff is coming from static components, which are composables from Figma data, and our dynamic components don't have any of that functionality. And this is a very easy fix. We're going to take our text and we're going to change it to a label, which is our cool text that renders Figma data. And we're just going to pass the ID that we're using to get to this dynamic component along. So now we'll render a static component out of all of this. There's our ID. I forgot that I highlighted it. So we're basically short-circuiting our little flowchart, and now the dynamic component is going to call a static component, which is going to get our nice Figma data. And now our link is blue, and our client is happy, and you can click it, and code is executed. I'm going to take a drink of water, because my slides tell me to at this point. I have 16 minutes left, so I'm going to go through lists, which is more complicated and more interesting, and how this finally solves our problems. A very good silence, thank you. All right, so for our lists, we want to generate an arbitrary amount of data, right? We have some number of elements with some data that we're getting from probably an API. The designer's not going to know what's in it, but they're going to know what the list items look like, right? So we're going to start, as our designer, by making another auto layout in our Figma, and we're going to call it something collection view. So list item collection view. And our parser is going to use this name, the fact that it contains collection view, to create a new type of structure for us. And we're just going to skip all the JSON because we've heard it a million times. And all we're getting from this is the direction. So we want lists that are horizontal or vertical. Now we can make a collection view composable again. And in this case, lazy column and lazy row actually call content off the same lazy list scope, so we don't have to create any wicked new functionality here. We can just decide which one to call based on our direction and just pass along our content. Now, our items are a little bit complicated because there are nested layouts. And the other thing we have to deal with now is instead of title, description, and price, which are static text, we want to show a title, description, and price. So for example, towards the bottom, we have an expensive item worth $600, and it's maybe gold-plated. And we have a free item that's free, and it has a description as well. So we want to get data down to our composables. Let's start by writing some dynamic components, which we were doing before, to kind of manipulate this data. So we're going to assume that we're going to get a myListItem, which is just a class with some strings in it, as a parameter in our dynamic components. And then all this dynamic component is going to do is fetch the title from our cool class. And same thing for all the other ones. So now we have annotated with our cool annotation, list item title, and it's going to display the title from a list item. And again, it's important that these are the same names as the Figma, because now when we try to call a layout and we try to fetch these by ID, we're going to run into these dynamic composables instead of our static content. So now we need to get this data in here somehow. And these dynamic components are being called from our generated code, right? So let's go into our generated code and make some changes. The first thing we're going to do is add data to our generated function. So we're going to take data as a parameter along with our ID. Next thing we're going to do is in our annotated functions, we're going to have our annotation processor check for a parameter named data. And this can be of any type. And we're going to remember what type it is, because when we generate the branch for calling this function, we're going to cast the data received as a parameter in dynamic UI composable to the type of the data in some composable in our code. And we're just going to pass that as an argument. So now anytime we call dynamic UI composable, we can pass data in, and that will propagate data down to the dynamic components that it fetches. While we're here, I'm not going to explain this just yet, but we're also going to do the same thing for Figma Composable by ID, and we'll get back to that in like 5 slides. These are updates to the annotation processor. And now we have another problem. We're passing data into our dynamic components. Wait, what is this slide supposed to explain? 1 second. Our problem is we're trying to propagate data all the way down through our tree. And our tree can be nested linear layouts. So we also need our linear layouts to pass data throughout everything. For now, let's just worry about the dynamic components, I think. Because when we run our code and we have an annotated dynamic component that takes a data parameter, our generated function is going to correctly grab its data, cast it, and pass it along. So that's working fine. I think someone's calling me. But now we added that parameter to Figma Composable by ID as well. So we want to accept that parameter in Figma Composable. And the reason is because we want to pass it through to our linear layouts, because our linear layouts also need to pass data to their children. So now when we get Figma Composables by ID, we can also pass them the data, and that data will get passed to linear layouts. And linear layouts are going to receive this data, and they're going to pass it along to their dynamic UI composables. So we're coming full circle here. Let's take a look at how this looks a little bit. So we have a linear layout that has some data set to it. It's going to call dynamic UI composable with the data. That data is going to get passed into Figma component by ID, and then that data is going to get passed into linear layout, which will again recurse this and generate more children. And if at any point dynamic UI composable finds a dynamic component, it will pass data into that dynamic component, which is what we need. So all of our leaves of our tree are now getting data from some root. The issue we have to address now is how is that first linear layout getting data? And the answer is our collection view is going to give it to it. So we're going to write a new collection view called items collection view. And this is just going to render one item over and over for some particular data set. It's going to take items as a parameter. That's going to be an iterable type, so we can iterate over it. There's going to be some generic type. We don't really care about our type right now. Items as a parameter. We're going to iterate over our types. And for each one, we're going to call the item function of lazy list scope. And we are going to create a dynamic UI composable once again. And we're going to pass our data into it. But at this point, we don't know what ID to pass here. So we've got to go back and address that issue real quick. We're going to go back to Figma. And we're going to update our parser to just take the first child of our collection view and call that the child. And that element is just going to be repeated over and over in our code. So jumping back to our code, we will now check to see if that child is not null. If it is, we will do absolutely nothing. But it shouldn't be. And we will pass that ID in to the dynamic UI composable, which will then look up that element and render it to the screen. So now collection view is passing data to our list item linear layout. All the orange lines are where data is flowing. The problem is we now need a collection view to get the data from somewhere, and we'll be done. And to do this, we can create another dynamic component, some more functionality. And this dynamic component is responsible for getting the list that we're going to render. So this knows how to get a view model, and it uses the lifecycle view model compose extensions, which is a separate library. So by default, it's just going to fetch a view model, but if we really wanted to, we could pass a view model in here. We won't. It's going to fetch a list, which is a list coming from a flow, so we're collecting that as state, and we're passing that into the item collection view that we wrote earlier. So once again, this is how data is flowing. The data is getting passed into a collection view. The collection view is now iterating on that data, passing it to a list item. That list item is creating more children and passing that all the way down the chain. So this is wonderful. So at this point, I'm actually ready to show a demo because we've shown all the code that would generate a working demo for us. I'm going to sidetrack real quick and handle multiple item types just because it's an interesting topic. So this is our items collection view that we just used. This takes items and it just renders one component over and over for it. And what if we want to do multiple? What if we wanted headers or like multiple item types? What we can do is use our other collection view, which that items collection view is using anyway, which exposes the lazy column scope and just kind of hijack that and write our list rendering logic directly. So we can fetch our list as before from a view model, but instead of passing list directly to item collection view, we'll take collection view itself and we'll fill in our own content. We will loop through our list items. Every third item we'll put a header, whatever. And then we'll check the type of our item. And if it's my list item, we'll render a list item. And if it's some other type, we'll render something else. So it's nice and convenient. We can create a list that has many different types. And a UI designer just has to plug in a list item collection view to get this behavior. And we can create multiple of these dynamic components. For example, we could create a list item 5 collection view, which displays a header of every 5 elements, and just change how often we're displaying the header. And I mean, we'd probably call the same base function here to not rewrite all this code, but whatever. So that's an interesting way we can do multiple item types. All right, at this point, we're ready for a demo. The demo is very exciting. It's the only reason I'm here, to be honest. Let's see if our video loads up. Oh, geez, I'm gonna have to figure out how to click play here. Okay. So on the right, we have the Android emulator, and on the left, we have the Figma that's tied into this app. So right now, we're displaying that locations page that we showed when we started the presentation. It's just a vertical list. It's got its rounded buttons. You can barely see it, but the quality will improve when I hit play. And the Figma, that's where it's coming from, right? So we're going to make some radical changes to our Figma. Come on. All right. We're going to make some radical changes to our Figma. We're going to start by changing the collection view to be horizontal instead of vertical, which is a long process for a reason I won't explain. Then we are going to change our cards to be square to work better in a horizontal layout. We're going to rearrange all our items, and we're actually going to just completely remove one of the items, which is our miles, like distance view thing, whatever, because we don't really have space for it. We're going to go ahead and align things a little better. We're going to center things. So all we're doing now is Figma changes. We're going to wait for all that to go through. Centering text, putting it in containers so that it has nice padding to it. God, I'm so tired. Center, center, center. Come on, hurry up. Next, we're going to go absolutely goblin mode, and we're going to change our UI to a dark theme instead. So we're going to make a dark gray location card. We're going to change the text to the wrong color so that it doesn't contrast, but don't worry, we'll go back and fix it. We are going to take our button, we're going to get rid of the rounded corner, so we're going to do that square button from before, and we're going to make it like Bear Burger's square button and give it a border. Border. The border is also going to be the wrong color. We'll fix it. Next, we'll take the whole screen and we'll make the whole screen dark to complement our dark gray card. So we'll set that to a pitch black once I find where the fill is on the screen. And then, just to go even crazier, we're going to take the map and we're going to throw it on the bottom of the screen instead, once we finish accidentally dragging the entire screen around. We're going to make it a little taller. We don't need the vertical space since we don't have a vertical list anymore. And we're going to go back and fix those things because I've just noticed that everything looks terrible. So now our UI looks decently okay, pretty pleasant. This might be something that a client requests. That's my motto. It might be something the client wants. This kind of even looks like the Kava app if you've ever used it. And we're going to run a script that just parses the JSON from this, throws it into our Android assets folder, and runs our app. And our app's going to parse this from assets. I went ahead and clicked the favorite item just to show that favorite functionality persists. That's another dynamic component based on that like little heart element on Figma. And I'm also going to point out that the map in Figma is just a big blue box, which isn't a map, but that has the name locations map, and we have a dynamic component called locations map, so that's going to hijack our renderer and render in Google Maps. And at this point, actually, Google Maps doesn't have Compose support, so that's even rendering an Android view. So we got some good interop going. We're just going to stand around awkwardly while this runs. You guys know about flossing? All right, our app is now running. And it's in a dark theme, crazy. We've got our location cards scrolling horizontally. Our favorite buttons even still work, and it remembered our favorites from last time. Our map is rendering, and everything is absolutely wonderful, and I accidentally reset the video instead of pausing it. So this is really cool because I didn't change the app at all. And in theory, we could have this run on our CI, and whenever the Figma designer makes changes, have our CI rebuild the app. We can have this come from a REST API, and at runtime just fetch what our configuration is supposed to look like. It's server-side UI, fully functional, and we can make more dynamic components, like for a clickable card, and not use our Order Now button anymore. Pick and choose elements. This is very cool. We did gloss over a lot, though. Let's see if I can change the slide, because in practice I had a hard time. OK. We did gloss over a lot. Obviously, we didn't talk about sizing at all, or weights. Distribution and alignment, borders. These are all modifiers that I didn't want to get too deep into because we run into some issues because we're using our own measure policy. We have to create our own scope as well instead of using row scope and column scope. But that is all functional. It can all be done. We kind of glossed over that we were passing modifiers down from dynamic components and from our dynamic UI component method. We glossed over the fact that we're using Figma components here and then using instances of components in our screen. And that lets us generate like cool stateful components. And our dynamic UI or our dynamic components can choose which state is being rendered based on some condition. So that list has an empty state. When the list is empty, it'll render an empty list. And when the list has items, it'll render item cards. Similarly, our button has a disabled state, and our favorite button has a selected and unselected state. Very cool. We skipped over string placeholders and substitution. So designers can write some copy on the screen and only substitute parts of it. So in that case, you can add like a location colon and then backslash parentheses, and it'll say location Walnut Creek, which maybe our client wants, who knows. And we didn't talk about fetching fonts, but that's just stored in our assets folder, and we're just using the name to look up the font we're using. But we can change fonts in Figma as well, not just the colors. Some things that are entirely missing from this project, there's no support for localization. I think Figma was working on something like a strings library, which we can use kind of as Android resources. But right now, all of our text is pretty much static. If it's written there, that's how it's going to appear, and we can't really translate. Luckily, we're only developing for US clients at the moment, so this isn't like huge on our radar. There's no type safety for data. That like data thing was a little disgusting. But we can have it crash like violently by casting with an as instead of like an as question mark, so we can find these things in development and during QA. And something we wanted to do but never got around to was defining like complex lists in Figma, but there's just no like great way to define them and then have the parser figure it out. So instead we just went with making several dynamic components. I want to give a special thanks to some of the people who made this presentation possible. There's Charles Whitson from the Android team at Lunchbox, who really took a lot of the architecture for this and made like a bunch of components for it, and really ran with this and implemented it across many of our screens. I want to thank Ethan Butler, who is now at SumUp, who wrote the entire parser and helped build this stuff on web as well. I want to give a shout out to the whole mobile team at Lunchbox, who dry ran this presentation with me and gave me a lot of good feedback, and especially my girlfriend, who I ran this with like 5 times, so she had to hear this so many times. And I want to thank you, the audience, for showing up to the last talk of DroidCon. It's a pretty full room. This is my first presentation ever, so it's pretty exciting. I'm sorry it was so fast, but they are recording this, so they'll probably upload it somewhere, and then I will probably tweet out the recording. So you can follow me on Twitter. If you try to add me on LinkedIn, I probably won't accept your request. I have like 100 pending. Yeah, thank you so much. I don't know if I'm allowed to take questions, but unless they say no, if anyone wants to come to the mics and shoot some questions. What's up? Yep.
Yeah, thank you. Great presentation. I have a quick question. You were mentioning with multiple view types, like in the recycler views, it supports already for like headers, body types, etc. But sometimes you might have like similar view types, and then you just want like ever so slightly one element differs. Like let's say one of those restaurant prices, you got it on a promo or a coupon, whatever. So you want to highlight it. Does that also support those like very granular distinctions between the same view type, or would you have to distinguish between them for even those minor changes?
Right. Let me just run back in my slides to that example. Yeah, so you can just have items that like extend each other. So you could have like a promo cart item and a cart item, and they can have the same data. And just based on that type, you could choose to render a different composable. And your composables can call other composables still because it's Compose and it's wonderful. So you could render like, if you're showing the promo at like the bottom of a cart item, I'm imagining, you could just still render this same list item, and then other list item could render list item as well with like a little attachment to it on the bottom. So there's definitely some stuff you can fish around with and like fix around. So that's a great question. But because this is just running arbitrary code, you could really do a lot with it.
Thank you.
All right. If no one else has any questions, I'm sorry this presentation was so dense, but thank you so much for indulging me.